we are going to solve this problem. What we have to calculate is the slope at B in this structure. First of all, we split the structure into parts. The part EDC, that is the left part, with the applied force at P, and the applied force P at cross-section D. We have to write the reactions at pin support E and the internal forces in the hinge of cross-section C. We have minus the shear force at C. I write minus B sub C because I know that this force is upwards, and we have the vertical and horizontal reactions at the pin support E, and moreover we have the axial force N sub C. Okay, we have N sub C. It is important not to forget N sub C. The distance between E and D and C is L in both places. Sorry. And if we calculate the addition of moments with respect to E, what we can calculate is minus B sub C. And what we obtain is that this vertical force is upwards equal to P divided by 2. Okay. So if we write the right part, what we have in the cross-section C is the opposite internal forces. That is the axial force N sub C pointing to the left, and the vertical force downwards equal to P divided by 2. That is minus B sub C equal to P divided by 2. Okay, so I can add to these two parts the relationships in terms of deformation. That is, the deflection, the vertical deflection of cross-section C is the same vertical deflection on the left and on the right side. Okay, but this equation is not valid because the left part can rotate around cross-section E. Then what we can write is that the horizontal deflection of C in the left and in the right side is the same value, has the same value. Okay, so I can use this equation to obtain the unknowns that we have, that in this case is the axial force. I need to calculate the axial force, and I'm gonna use this equation of this equality of horizontal deflections. Okay, so I can calculate the deflection of C in the left side. That is equal to the effect of the axial load N sub C, that is the lengthening of this bar, N sub C 2L divided by the cross-sectional area and the Young modulus. In the right side, the deflection of C, the right side, depends also on N sub C, that produces a lengthening of the bar CB, that is minus N sub C multiplied by the length CB and divided by the area of the cross section multiplied by the Young modulus. And from the other side, well, this is because of axial load, okay, in CB. And in the other side, I can calculate the effect of bending in AB that produces a deflection of C, that is through the deflection of B. Okay, so the deflection of B because of bending in the portion AB is gonna be equal to the effect of the translated forces and moment. That is, I I have to translate this vertical load P divided by 2, okay, minus V sub C. Also I have to translate N sub C, and because of the translation of P divided by 2, I have a moment that is counterclockwise P divided by 2 multiplied by L. Okay, so the deflection of B is equal to deflection of B to the right side is equal to P divided by 2 L, the moment, multiplied by L AB squared divided by 2EI, minus the effect of N sub C, that is to displace B to the left side, so minus N sub C L AB cubed divided by 3EI. Okay, so taking into account all the calculations, I can write the equality in sub C multiplied by 2L divided by AE equal to minus N sub C L divided by IE plus PL cubed divided by 4EI and minus N sub C L cubed divided by 3EI. Okay, so now we have to take into account that the deflection because of axial load, this term and this term are very small in comparison to the deflections because of bending. Okay, 0 equal to PL3 divided by 4EI minus N sub C L3 divided by 3EI, so N sub C is equal to 3 divided by 4 P. Okay, now once we have the value of the axial force in the horizontal part of the structure, we can calculate the slope of B taking into account the vertical part of the structure, that is AB with the force, the vertical force P divided by 2, N sub C, and this moment PL divided by 2. So this slope of B counterclockwise is equal to PL squared divided by LAB divided by EI minus N sub C multiplied by LAB squared divided by 2EI. So this is PL squared divided by 2EI minus 3 over 4 PL squared divided by 2EI. So this is equal to 4 divided by 8 minus 3 divided by 8. 4 divided by 8 minus 3 divided by 8, PL squared divided by EI. The two is wrong, so the result is 1 divided by 8, that is PL squared divided by 8 EI. That is the slope of B counterclockwise.